Picture class, in this video we're going to look at alterations of cosecant or secant functions. So when you're doing this problem, it could say cosecant, it could say secant. But when I alter a cosecant function, I'm going to start off with the sine function. So here's sine. It starts off on the midline, it rises, it falls, it rises again. There's one period of the sine function. All right, this is 0, this is 2 pi. All right, this right here where it hits the midline again happens halfway between those two. And then the quarter periods, that's pi over 2, that's 3 pi over 2. All right, so that's just sine. All right, if it's just sine, then this happens at 1. This is down here at -1. Now ours isn't that. Ours is -3 cosecant 1/8 x. So why are we talking about sine? Well, the way we graph cosecant is through sine. So we're going to look at what would happen if this were sine, if that were the only thing different. And so the first thing we have to do is come up with what would this right end be because of the 1/8. Okay, so when we are coming up with the period, I always like to take my inside. Right, so this typically happens at 0 and 2 pi. So I take the inside of the sine or cosine and set that equal to the left and right end. So I set that equal to 0, I set that equal to 2 pi, and then I solve for x. So multiplying both sides of this top equation by 8 to solve for x would give me still 0. So this still happens at 0. That's going to be on the y-axis, so that's 0. And then this other one though happens if I multiply both sides by 8 to get rid of that 1/8. I'll have a 16 pi. So this right end is going to be at 16 pi. And so we're going to leave the midline at 0. We're going to return to the midline halfway between these two at 8 pi. And then we're going to return to the midline again at 16 pi. But because it's a negative, sine typically goes up that way off the midline. But because of the negative, we're actually going to fall. All right, we're going to fall, we're going to bottom out, we're going to rise, peak, and then we're going to fall again. All right, the bottoming out and the peak happen halfway between 0 and 8 pi, so at 4 pi, and between 8 pi and 16 pi, which would be 12 pi. And then the last thing is, okay, well, where do the low points and high points take place? Well, this low point happens at the amplitude -3. The high point happens at the other, the negation of that basically, so at +3. So there's what one period of the sine function here would look like. All right, now that's the sine function. Okay, we got to understand that's sine. We need sine to graph cosecant, but this is not the end of the graph. So what we need to do next is everywhere that we hit the midline on the sine function, that actually becomes a vertical asymptote in the cosecant function. All right, and then as we hit the peak and the valley, those are going to be on both. That's on the sine and the cosecant. Then we move away from those peaks and valleys towards those vertical asymptotes in the cosecant function. All right, and then ultimately, I'm just going to go in here and just dash this, because this is needed to get us our foundation, but it's actually not part of the graph, just like the asymptotes aren't. Always dash asymptotes, but don't dash the sine, cosine functions that help us graph cosecant and secant. So the red, that is the actual graph here that I'm after of this cosecant function. The dash sine graph is just kind of the foundation for it. Right now I'm just looking at these to try to see which ones match up with what I'm seeing. Okay, so I need vertical asymptotes at 0, 8 pi, and 16 pi. So vertical asymptotes at 0, that's got it, 8 pi, 16 pi. So it could be A. At 0, no. We got a point on the graph, so B is out. So no B. All right, vertical asymptote at 0, no. C is out. All right, vertical asymptote at 0, 8 pi, and 16 pi. So it could be D. All right, but then look at the pattern of the peaks and the valleys. All right, here between 0 and 8 pi it's up. Between 8 and 16 pi it's down. Here between 0 and 8 pi it's down. Here it's up. And if you look at our drawing, it needs to go down in the first one and up in the second one. So down, then up. There's down, then up. This up, then down. So now D is out. So A is our answer. All right, and then let's look at the domain and range. So what is the domain and range of this? Domain is everywhere except where we have vertical asymptotes. And if you look at our graph again, we're having vertical asymptotes every multiple of 8 pi. So 0 times 8 pi is 0, 1 times 8 pi, 2 times 8 pi, 3 times 8 pi. So multiples of 8 pi, where k is an integer. So that would be choice C there. All right, and then what is our range? So secant and cosecant have this really bizarre range where the sine wave or the cosine wave is taken out of the range. So, it would be all real numbers, but we had this little wave here that's not included. So it ends up being negative infinity all the way up to -3, and then +3 all the way up to infinity. So we're just taking negative infinity to infinity and taking out the range of that sine wave. So it's all numbers below -3 or above +3 is our range for this one.